Everybody. I am Victoria Inebeli, and I have my co-host here, Toby. So I'm going to be officially introducing you all to the Ethereum Blockchain / network. So before I continue, I would like to let you guys know that at the end of this section, we're going to be having a giveaway section actually. We have 4 questions and we're going to have 4 lucky winners. Basically, we're going to be giving out 20K. So it's going to be 5K per question. So once I announce this question, my coach is going to type the question again in the chat box live there on YouTube. So once it types in this types out the question, you can start answering. The fastest and most accurate person gets to win the money. So also, if you are going to be answering any question, please attach your Discord username because we're going to use that username to identify you on Discord for your payments. So yeah, when it comes to Ethereum blockchain, we're going to be considering some things like the history of Ethereum, the definition, the features, use cases, languages for smart contracts, Ethereum accounts, the tools for development, Ethereum frameworks, the development environments, Ethereum network, and some other words in Ethereum. So let's start immediately. So yeah, the history of the Ethereum blockchain. So basically Bitcoin was year before Ethereum, right? Yeah. So the main goal of Bitcoin was to serve as a decentralized global digital payment system using a peer-to-peer model. So but with Bitcoin being so popular, developers were actually looking for ways to build applications on this amazing new technology. But there was a problem. The fact that Bitcoin blockchain was actually rigid by design and could technically be said to be Turing incomplete, which made it very hard for its source code to be tweaked to perform other use cases apart from its main goal. Now, what do I mean by Turing incomplete? Let me give a very local illustration. So let's say we have a robot that was designed to actually sweep the floor. Now, that robot was designed to sweep the floor. So definitely that is what it's going to do, sweep the floor. The robot is not going to be sweeping the floor and then see clothes on the floor and pick it up. No, it's just going to focus on what it was designed to do. If you want the robot to do other things, then it's going to be very, very hard for you to make it do other things. Even if it's possible, it's going to be really, really hard. So we can say that robot is Turing incomplete. It's just designed to do what it's supposed to do, and that's what it's doing. Then let's say you employ an house girl, and the house girl is supposed to cook. That's what you employed her for. Supposed to cook. But then you can easily make her do other things like clean the house, wash dirty clothes, and all that. Now that girl can be called Turing complete because even if you employed her to cook, you can easily just change her purpose. You can easily just like make her do other things apart from cooking. So that is it. So Bitcoin is basically Turing incomplete. We could developers found it very, very hard to build decentralized applications on the Bitcoin blockchain. So in 2013, we had Vitaly Buterin talking about Ethereum. He actually introduced it in his article as the ultimate smart contract and decentralized application platform. Yeah, and in 2015, this was brought to life. We had the Ethereum blockchain. So what really is the Ethereum blockchain? Ethereum is a decentralized world computing platform that enables decentralized applications to run. It is a Turing complete blockchain. The main components of a DApp are smart contracts, and it is hosted and run on the Ethereum blockchain, but not for free. So the way we have our normal bank apps, the way we use our bank apps to transfer money from one person to another, and then we pay transaction fees. That's the same way we pay gas fees on the Ethereum blockchain. For you to do anything, deploy your smart contract, you have to pay gas fees. The way you pay transaction fees in your normal bank app, let's say Nigerian bank app now, you pay transaction fees using Naira. And then these transaction fees you pay, they are used to maintain the system and pay workers and all that. That's the same way in Ethereum. Ethereum has its own cryptocurrency called Ether, used to pay for gas fees. And these gas fees are paid to miners for validating and adding transactions to the blockchain. So based on where Ethereum is coming from, we can actually say Ethereum is the world programmable blockchain. It is a marketplace for financial services, games, apps, and so many other things that can steal your data or censor you. So that is it for Ethereum. So let's talk about the features of Ethereum. So Ethereum has so many features. We have the first one being the fact that Ethereum is actually secured. So why is Ethereum secured? It is secured because it is almost impossible to tamper with any transaction in the block or to add any fraudulent block in the network. Yeah. So Ethereum has this large community support also. In that when Ethereum actually came on board, it attracted a lot of people. It attracted attention all over the world. And so, yeah, it has this very large community support. It is also corporate friendly in structure. That is, we have so many platforms leveraging on it. Yeah, we have so many corporate leveraging on it, building and testing different applications. Then we also have the aspect of asset issuance, in the sense that with Ethereum, we have the possibility of creating so many assets, new assets that can be used as currencies. Then also, Ethereum is fast compared to Bitcoin. Bitcoin was there before Ethereum came in. Yeah, Ethereum was built based on the innovation of Bitcoin, but this time Ethereum is not very, very fast when it comes to Bitcoin, in the sense that while Bitcoin requires a block time of 10 minutes, in Ethereum, it only takes a few seconds. And then we have the fact that Ethereum is uncensored. So what does it mean for something to be uncensored? Let me give an illustration. So let's say you're using Twitter and then you post something on Twitter. Twitter has the right to ban you if they don't like your post or take down your post. But when you have decentralized social media applications built on the Ethereum blockchain, it is actually uncensored, in the sense that no one can ban you or take down your post, except everybody using that, majority of people using that social media account, actually, social media platform, actually votes that a post be taken down. So yeah, we have Ethereum use cases. So there are so many use cases in Ethereum, but I'm going to be considering just two. There's so many use cases in Ethereum, like we have use cases in when it comes to health, we have health applications and all that. I'm going to be considering just two, which is the DeFi and the NFTs. So DeFi fully means decentralized finance. So it's a network of financial applications built on top of the blockchain network, basically Ethereum in this case. An example include examples include Aave and Uniswap. Then we have the NFTs. NFTs are basically unique digital assets on the blockchain. It gives you this idea of owning a very unique something, owning something that is unique, owning something that nobody else owns. That's what NFTs is all about. And they are created using the ERC 721 standard. Yeah. So when it comes to decentralized applications, you actually build them on the basis of smart contracts. And these smart contracts are written using languages, just the way you want to build a website, you use your HTML, CSS, and JavaScript. So the same way if you are building decentralized application, you also have to use a language to write the smart contracts behind it. Yeah, so we have so many Ethereum languages. We have Viper, we have Serpent, we have Mutant. Mutant is deprecated though. We have Julia, we have L4, and so many more. But the most popular is Solidity. So what is Solidity? Solidity is an object-oriented high-level programming language used for the implementation of smart contracts on the Ethereum blockchain. It was influenced by Python, C++, and JavaScript. That is, if you know Python, C++, or JavaScript, any of these three, you find some similarities when it comes to Solidity. And it is designed to target the EVM. It is designed to target the EVM. In addition, it is the most popular language for smart contracts, just like what I said before. Yeah. So in Ethereum, we have the Ethereum accounts. So basically, we have just two accounts in Ethereum. We have the EOA and the contract accounts. EOA simply means the externally owned accounts. And then the contract accounts, based on the fact that it is actually has to do with smart contracts. So what is an EOA? It's an account controlled by a private key. You can use this account to send and receive Ether to and from other accounts, and they are freely created. For example, Binance accounts, MetaMask accounts. When you want to create this account, you just create them for free, and you get your private key and your public address. Yeah. So basically, an EOA has an Ether balance. It has the ability to send transactions. It is controlled by a private key and has no associated code. Yeah. Then we have the contract account. So a contract account definitely has an associated code because it has to do with smart contracts. A contract account is one that has an Ether balance, has an associated code, where code execution is triggered by transactions or messages which are received from other contracts. And then this contract account actually has the ability to perform operations of arbitrary complexity once executed. And of course, it is not for free because it has to do with smart contracts. So definitely, you're going to be paying gas fees to deploy the smart contracts for you to get your contract account. Yeah. So that's it for Ethereum accounts. So basically, we have definitely there always have to be development tools here. So when you're building your DApps and all that, you need development tools. So for Ethereum, we're going to be considering 8 major development tools. We have Get, Ganache Clay, Parity, MetaMask, the Mist Wallet, Swarm, IPFS, and Whisper. So what is Get? It is a multi-purpose command line tool that runs an Ethereum node implemented in Go. It is the official Golang implementation of the Ethereum protocol, and it is commonly used to interact with the Ethereum network. It is a command line interface used when running a full Ethereum node. Then we have Ganache. So it is actually fast and customizable. It is a fast and customizable blockchain emulator, which allows you to make calls to the blockchain without running the actual Ethereum node. So you don't need to actually run the actual Ethereum node when you're using Ganache Client. Then we have Parity. Parity is the fastest, lightest, and most secure Ethereum client that provides the core infrastructure essentials for quick and reliable services. It is written in Rust language and provides access to a diverse range of Ethereum futures, including, of course, decentralized applications. And then we have MetaMask. By now, most of us would have heard of MetaMask. In fact, everybody should have heard of MetaMask. Yeah, it is a browser, it is browser-based. It actually turns your Google Chrome into a browser that allows the user to send and receive transactions and also fetch data from the blockchain. It permits you to run Ethereum DApps directly from your browser without the need for running a full Ethereum node. And then we have Mist Wallets. So what is a Mist Wallet? It is the end user interface for Ethereum that is developed for browsing and using decentralized applications. It is an official Ethereum wallet. We have Swarm. Swarm is a platform that supports distributed storage and provides content distribution services. It provides sufficient decentralization and redundant storage of Ethereum records to distribute blockchain data as well as decentralized application codes. And then we have IPFS. This one is really, really popular. Many of you would have heard about it. IPFS simply means Interplanetary File System. It is a decentralized storage system that is not related directly to Ethereum, but can be integrated with it. It stores data by use of a distributed hash table. And then the last one, we have Whisper. So what is Whisper? It's an identity-based communication protocol for decentralized applications to interact with each other. For example, a DApp running a currency exchange may use Whisper to record and offer to buy a cryptocurrency at a pre-agreed price on the exchange platform. So that is about the 8 major tools for Ethereum, for developing on Ethereum. So yeah, we have Ethereum frameworks. So just like in Web 2, we have frameworks like Bootstrap and the rest. We also have frameworks in Web 3. Yeah, so I'm going to be considering two, Web3.js and Hit.js. So what is Web3.js? Web3.js is a set of library which permits one to interact with a remote or local Ethereum node. It's actually the key connection between Ethereum network and decentralized application that allows you to compile, deploy, and interact with smart contracts. Basically, what Web3.js does is that it gives us a way to build a website that can talk to the Ethereum blockchain. Yeah, so basically Web3.js and Hit.js have the same goal in mind, but they are different. Where Hit.js is actually, it is a highly optimized, lightweight JS utility for Ethereum. So basically both of them actually just helps us build a website that can actually interact with the Ethereum, that can actually talk to the Ethereum blockchain. So we have Ethereum development environments. So yeah, if you want to develop a smart contract, you have to develop in an environment, just the way we have in Web 2, we have environments for developing websites. We also have environment for developing smart contracts. And the most popular, the three commonly used are Remix, Truffle, and ADAT. In fact, many of us would have heard about these three. If you have not heard about ADAT, you should have heard about Remix. And their videos have been released concerning how you can use Remix. In fact, example code that was even deployed using Remix. So Remix is browser-based. Yeah. So basically, these three things are there to just help you deploy, build, actually code, test, and deploy your smart contracts. But basically, they are different based on you decide to use the one you want to use based on how comfortable you have with the three of them, with any of them. So, but Remix is the most simplest. It's the simplest. You just have to go to your browser, type Remix, and then you gain access to the IDE, which is browser-based, and then you do your thing, test your code, and everything just runs smoothly. So we have the Ethereum network. We have the what? The Ethereum network. So yeah, Ethereum is a decentralized blockchain platform that establishes a peer-to-peer network of participating nodes that securely executes and verifies application code called smart contracts. For those that do not know what a node is defined as a device or a program that can communicate with the Ethereum blockchain network. It serves as a machine running as an Ethereum client. So when it comes to Ethereum network, we basically have three. We have the private network, we have the test network, and the main network. I'm going to be considering the test network and the main network. So basically, why do we have the test network and the main network? So the same way in the real life, you get to rehearse before going to present a speech. That's the same way you get to test your decentralized application before pushing it out to the public for everyone to access it. If you don't do this, you end up having errors in your decentralized application. The same way, if you don't rehearse before going for your speech, you end up saying rubbish in your speech. So yes, that's the same way we have testnet and mainnet. So what is the testnet? It's actually a simple way for programmers and developers to create, modify, and test the functionalities of their projects, as well as monitor the performance before making it accessible to the public. Note the word before making it accessible to the public. That is the main point. That is the main reason why you are using the testnet first. To test and do everything before making it accessible to the public. So the testing allows for the full testing of a blockchain project without interfering with the transactions on the main chain, because on the mainnet, it will not make so much sense for us to be testing on the mainnet and then we have real transactions going on there. It's going to be messed up. Besides that, if you want to test on the mainnet, you're going to spend a lot, because on the mainnet, on the testnet, you use fake Ether to test your transaction. You won't get free Ether self from all these faucets and use to test your application or your smart contract. But in the mainnet, things are not for free. You pay for everything you do. So if you are going to be testing on the mainnet, it's even a bad idea because you're going to spend so much trying to test an application. So the testnet is here for you. So the testnet uses fake money or tokens without value to run their protocols. So basically, a testnet actually allows for safer launching to the mainnet. And yes, what is the mainnet? It is the main network, obviously, that's a blockchain project run on. So when you finish testing with the testnet, you deploy to the mainnet. Yeah. So what next? We have some terms in Ethereum. So some terms in Ethereum like Ethereum Wallets and the Ethereum virtual machine. So on these words have actually been discussed on the Discord channel before. I remember opening a conversation about wallets and we discussed a lot. And then if you check the compiled gas, you actually get to see a definition for Ethereum virtual machine. But let me just talk about it a bit. So what are Ethereum wallets? Yeah, so basically an Ethereum wallet just stores your private key. It doesn't store your cryptocurrency or your money. It doesn't store your cryptocurrency. It stores your private key. The blockchain stores your cryptocurrency, but the wallet stores your private key. And with this private key, you can get to see, you can get to make transactions and see your wallets, your cryptocurrency balance and all that. Then we have the EVM. What is the EVM? It's an engine. First of all, when you have smart contracts, these smart contracts are processed by the EVM. For the EVM to process the smart contract is actually compiled into what we call bytecode. And it is this bytecode that the EVM understands. Yeah. So what is the EVM? Before I proceed, the EVM runs on every node. Every single node that has been set up on the Ethereum blockchain actually has the EVM running inside it. So the EVM is an engine that executes translation code. So smart contracts are compiled into bytecode, which an EVM can read and execute. The EVM uses a set of instructions called opcodes to execute specific tasks. So if a person triggers a transaction of 5 Ethereum using his desktop wallet, the wallet sends the message to the EVM, which then connects to a wallet address on the Ethereum network to process the transaction and then send the 5 Ethereum to the what? Sorry, send the 5 Ether to the receiver. You see, I'm even making a mistake there. Yeah, so what we have in our wallet is actually not Ethereum. What we have in our wallet is Ether, not Ethereum. So yes, some people say, I have 5 Ethereum in my wallet. No, Ethereum is the name of the blockchain. What you have in your wallet is called Ether. And that will be all for the Ethereum blockchain. So I'm sure many of you have questions. My co-host here, Toby, we'll be going through those questions. Like it will be asking me some questions. The one I can answer, I will answer. The one I cannot answer, I will give it to him to answer. So basically, we're going to be sharing this. Toby, please.
Yeah. I mean, we've got a couple of questions. You guys can start sending in your questions. Let me read those that I have at the moment. So we have the first question. What is the function of the EVM, Ethereum Virtual Machine?
Okay, yes. So I just finished explaining that. In case you didn't hear what I said, the Ethereum virtual machine is there to be able to what? To be able to read and execute our smart contracts. But it doesn't understand when we say what we are writing. So it only understands byte code. And these smart contracts are compiled into byte codes for the EVM to understand. So when the EVM gets the byte code, it reads and then executes the instruction according to what you have written down in your smart contract. So that's the work of EVM. EVM, the Ethereum virtual machine, is just there to help us process our smart contracts, and it runs on every node.
Okay. Someone's asking what's the difference between a node and a client, an Ethereum node and an Ethereum client?
So basically, Ethereum nodes can be called Ethereum clients. They're basically the same thing. Although, do you have any other thing to add to that? Because you can call an Ethereum node an Ethereum client. They're the same thing.
Okay, so that depends on context. A node could be described like a computer running an Ethereum client, basically. So Ethereum clients are like specifications and implementations of the Ethereum protocol. Examples, get and parity. So those are examples of clients. So any computer running like a get program basically is an Ethereum node. So that's just the idea. So exactly what you said. Next question is JavaScript the only programming language for Ethereum development? Blockchain development, basically.
If JavaScript is the only language for blockchain development,
Yeah.
then the language we're using for blockchain development is Solidity. So, but yes, Solidity has similarities with JavaScript, not only JavaScript, C++ and Python. So when it comes to frameworks, we have Web3.js and ETH.js. So basically what we're using for smart contracts is Solidity and not JavaScript.
Okay. We got another question. What compiles the smart contract to bytecodes or opcodes?
What compiles the smart contract?
To bytecode, byte format, yeah.
So basically when you deploy, when you type your smart contract, for example, in the Remix ID, we have a compiler that compiles it. So it is the compiler that compiles it into bytecode. Or Toby, do you have anything to say about this?
No, that's good. You guys should send in more questions. We only have one more question at the moment. Someone's asking, is the Ether.js library built on JavaScript?
Okay,
Yeah,
Toby, please answer that.
that's an Ethereum, that's a JavaScript library that helps us to communicate with smart contracts and on the blockchain, basically. Okay. Is it.js the same as ether.js? I think the correct spelling would be ethers.js, ethers.js. I think that was a typo. I'm just checking finally for questions. If you have any questions, please send them in the YouTube chat.
So please send all your questions to the YouTube channel so we can attend to them. And also remember, we're going to be having a quiz section. Should I say quiz section? No, basically a giveaway section to test your knowledge. So you are smart enough, you get to win money. So send in your questions, we attend to it, and then we start our giveaway section.
Okay. EOA. Sorry, I didn't get somebody typing a question. If you're typing a question, please like specify exactly what you're referring to. Okay, someone's asking as a Python developer, if I learn Viper, that is, if I learn Python, would I be relevant in blockchain field?
So please come again.
Someone is asking if I learn Python, is Python applicable in the blockchain field? What can I use Python to do in the blockchain field?
What can you use Python to do in the blockchain space? First
Yeah.
of all, if you know Python, definitely if you know any programming language before getting to learn Solidity, it's going to give you an edge because you're already in the programming line. So it's going to help you understand Solidity better. So when it comes to what you can do with Python in the blockchain space, Toby, please attend to that.
Okay, Python blockchain space. So there are multiple languages basically that Ethereum can run basically. So Solidity is just an example of a Turing complete language that can run on Ethereum. Another example is Viper. Viper is very similar to Python. So basically your Python experience could help you to learn these languages faster, and then you could also use Python to like automate like development process basically. So Python also has its own smart contract development framework, which is Brownie. So that uses Python too. So Python is also applicable in blockchain development, but JavaScript is more widespread. Okay. So we have another question. What are the different types of testnets? How can testnets be accessed on the virtual environment? I don't know what that means, but what are different types of testnets basically?
So we have different testnets. We have Ring2B, we have Robson, and so many others. So how do you use a testnet? Basically, you first of all, for you to use a testnet, you have to get free Ether from those faucets, and then you basically deploy to the testnet. Then we can add to this. Please add to this.
Different types of testnets. So basically to avoid congestion and like to replicate the Ethereum environment, like in different specifications and for different clients, basically there are multiple testnets that we can use to like test run smart contracts. Okay, so we have another question. What's the difference between a private key and an Ethereum wallet address?
What's the difference between a private key and an Ethereum wallet address?
Yeah.
So first of all, so basically when you create an Ethereum wallet, when you create an account, like to get an Ethereum wallet, something like that, you get a private key and you get a public key. So your address is like your public key. Your address is something that you can share. Anybody can gain access to it. You can tell anybody, just like your normal account number. Or your private key is like your password. So the address is something you can share. You can tell anybody. There's no harm in it. It's your private key that you keep safe.
Okay, another question. Is there a way to innovate Ethereum so gas fees will be cheaper or less volatile?
Is there a way to innovate Ethereum so gas fees will be cheaper?
Yeah.
So when it comes to gas fees being cheaper, so definitely there are ways you can write your codes that can make your the what you spend less. You understand? So for personally for me, that's just the only way I know. You are writing your code. There's a way you can write it that instead of you to spend probably 3,000 Ether, you end up spending 2,000 Ether. So but if there's a way you can innovate Ethereum, the blockchain itself, to reduce gas fees. So do you have anything to say about that?
Yeah, there also so you can also add like roll-ups and L2 solutions. Okay. So some people like maybe you make use of zero knowledge proofs to like optimize code, reduce the amount of data that needs to be transferred basically and speed up transactions. Example of that is Arbitrum and Polygon. Okay.
Yeah. Polygon. So when you deploy on Polygon, you actually pay cheaper fees.
Okay. We'll be taking our last question now. I don't know. Waiting for another question. Okay, someone's asking what is the best tool I can use to write my Solidity code? I think it's asking between Remix, Truffle, and Hard Hat.
So like I said, see, depending on your preference, you can try all of them and see the one you like. So, but every beginner has to start with Remix, since it's actually easy and easy to use. Understand? So, but when I can't tell you which one is exactly the best. Everybody have their preference. Understand? So when as you're growing, you get to test the tree if you want to test the tree, and then you say, okay, I prefer Shuffle over Adats. I prefer Adats over Remix. I prefer whatever. So it has to do with your own personal experience with them.
Okay. Someone asks, does that mean that big O notation of a contract can lower gas fees? It depends. Solidity works differently from a normal programming language. So the paradigms you use to optimize your normal code wouldn't be the same for Solidity. So for example, you'd want to minimize like reading and writing from storage. So it wouldn't be the same for like a normal programming language. But yes, if you can write your code in such a way that you reduce like transactions on the Ethereum network. Okay, we have another question. I think that's our final question. What is the correlation between private keys, public keys, and digital signatures?
So what's the correlation between private keys, public keys, and digital signature? So basically, you can send messages. you can send encrypted messages. You can send encrypted messages, and these messages you actually use a private key to sign it. So once you're sending a message that is encrypted, you sign it with your private key, and that's like your digital signature. If you had something, tell me if you have something to add to this, please add.
No, that's good. Yeah, you sign your transaction with your private key. That generates a signature, which is your public key. Okay, so that's like a signature. Your public key is your public signature that everybody can view, but nobody else can generate your public signature without the private key, based on the cryptographic primitives used to generate that public key. Okay. Yeah. Okay. This is the final question. I think we can get to the game night. Does the number of opcodes determine the gas fee cost too?
There's number of what?
Opcodes, operational codes determine the gas fee cost too.
Okay, so please take that.
Okay, so the number of opcodes is basically the number of like requests and like transactions your program is making basically. So yes, if you have like a larger number of opcodes, basically you're going to have like a larger number of transactions with the blockchain, which is going to consume more gas basically. So opcodes is like number of calculations and processes basically. Yeah, I think we can proceed to the game night.
Okay, so want to start the giveaway section. So please and please, once I read out the question, please, everything that should be typed on the chat box has to do should be related to the question, please. If you are typing on the chat box from now on, it should be that you are trying to answer the question. Don't type anything irrelevant so that we can easily see those answering and see the correct answers. Also, remember, if you are answering a question, add your Discord username to it so that when you answer and we mark you correct, we can easily identify you on Discord. If you don't stick to the rules, if you don't obey the rules, even if you answer correctly, we will not recognize that. So always endeavor to have your Discord username if you are answering any question. So the fastest person with the accurate answer gets to win the 5K attached to a question. So the first question, I'm going to read it out, and Tom is also going to type it on the chat box. But as I'm reading it out, if you already have your answer, don't wait for him to type it finish. Just start typing your answer in the chat box. Remember, the fastest and most accurate person. So the first question, list the 7 denominations of the native currency of Ethereum in descending order. List the 7 denominations of the native currency of Ethereum in what? Descending order. That is from largest to smallest. Toby, you got that?
Yes, yes.
So please let's start typing in your answers. You are lucky, 5K is a lot of money. You can use 5K to flex yourself at least for more than 1 day or 2 days. So Toby is going to be checking the chat box on the YouTube live. And once we have an answer and a winner, we're going to proceed to the next question. So Toby, please let me know if we have a winner.
Yeah.
Already.
Okay.
In case you didn't get the question correctly, list the 7 denominations of the native currency of Ethereum in descending order. The 7 denominations of the native currency of Ethereum in descending order.
Okay, we still don't have an answer at the moment.
Wow, is it that hard? Okay, we'll give them more time. But there are people typing in, right?
Yeah, okay. Do make sure you add your Discord name while you're sending in your submission. Okay. Um, I think we have an answer.
We have an answer.
Yeah.
Okay, can you so we have an answer, right?
That
So
would be sorry. Okay, Joseph Akoni sent Ita, Finney, Sabo, Shannon, Lovelace, Babbage, and Way. Okay, so that's the answer.
so you mentioned the 7 denominations, right?
Yes, he did.
Okay, cool. Congratulations. Joseph who?
Joseph Achonu underscore, his name is I am CO AYIAMCO.
Okay, so Toby, can you take note
I
of
have
that?
that down, yeah.
Okay, cool. So the next questions, please listen attentively. The next question. In Solidity, if you divide a signed integer -5 by signed integer 2, what is the result? And please attach a valid reason. In Solidity, if you divide a signed integer -5 by a signed integer 2, what is the result? Attach a reason for your claim, like what is the result, the answer, then tell us why you chose that, why you're giving us that answer. So we know you are giving us the right answer with the right reason. Toby, have you typed that down? Have you typed it out?
Yeah. Okay, we're on question 2, guys. So it's question 2. Now you can stop sending submissions for question 1.
Question 2, I repeat. In Solidity, if you divide a signed integer -5 by signed integer 2.
Okay, we have an answer from
Wow.
David Ekompu. David, he said you get -2 because the decimal part gets truncated based on the data type, which is correct.
So it's correct, right? Hello?
Yeah, it's correct. It's correct. Next question.
Okay. Congratulations, Ekompu David. So the third question, how many bytes long is an address? 1, public key, 2, and private key. How many bytes long is an address, public key, and private key? So once, how many bytes long is an address, public key, and private key? Toby, you got that?
Yeah. I'll put that down. Okay, if you're submitting your answer, please let it be a single post. I'm not going to read like 3 multiple posts. So we want how long is it? How many bytes and public address, your public key, and your private key. So we're expecting 3 values. That would be the length of an address, the length of a public key, and the length of a private key. And I want the answer should be in bytes as stated by the question. Okay, we have an answer.
Okay, that's
Okay.
nice.
Some
So
okay,
who
let
won?
me confirm. Let me confirm, sorry. Sam Olusola. He said private key is 32 bytes, public key is 64 bytes, and an address is 20 bytes.
Okay, that's cool. So congratulations, Olushola, right?
Yeah, Sam Olusola.
Cool. So the last question. So if you know you have not won 5K, this is your last opportunity. Oh. The last question. What is the full meaning of ZK snack? The full meaning of ZK snack.
Okay.
Toby, you got that?
Yeah, posted that. Question 4. Final question. What is the meaning of ZK snack? Full meaning?
Final question.
Okay. Okay. Think we have an answer.
Okay. So who won?
Confirm. Okay, we have Maisie, which is his answer was zero knowledge, succinct, non-interactive argument of proof. ZK snack.
Of what?
Zero knowledge, succinct, non-interactive argument of knowledge by Maisie. So that's the answer.
Okay, so congratulations, Maisie. So
Yeah.
it has been a wonderful section. For those that are not in the live section, or for those of us in the live section that didn't get the answers, I'm going to be reading out the answers to these 4 questions. We already have 4 winners. I'm going to be reading out the answers to these 4 questions. And then I'm going to be posting it in the compiled gas channel. In case you don't even get it, like really get it here, you can always go to the compiled gas channel and see the answers for these questions. So the first question was list the 7 denominations of the native currency of Ethereum in descending order. So we have Ether, Fini, Zabo, Way, M-Way, K-Way, and Way. The second question, in Solidity, if you divide signed integer minus 5 by signed integer 2, what's the result? Attach a reason. So division, this is the answer. Division on integers always results in an integer. In Solidity, division rounds towards 0. This means that integer 256 minus 5 divided by integer 256 2 will give you int 256 minus 2. So the third question, how many bytes long is an address, public key, and private key? So an address is 20 bytes long, a public key is 64 bytes long, and the private key is 32 bytes long. So the last question, what's the full meaning of ZK snack? It simply means zero knowledge, succinct, non-interactive argument of knowledge. So it has been a wonderful section. For those that did not have the opportunity to ask their question concerning the class, you can still show your question. We're going to give you guys like some minutes. You can still drop your questions in the chat box for us to attend to. If there are no questions, call it a day. I'll be a night. Toby, If you have
Yep.
something to say, please contribute.
Good. It's been a great class. We talked about blockchain, Ethereum as a blockchain. We talked about Ethereum tool and tooling sets. I believe we're ready to start building smart contracts. So great class.